Hey, what's up, guys? We're back into pre-calc. Let's get straight into it. Today, we're going to be talking about the GOAT polynomials. Let me just, you know, clean up our board and hopefully not lag today. Polynomials, by definition, it should have, let's make it a list. A polynomial is firstly continuous. So it'll never have an end. It'll never have like a hole or any type of discontinuity. It usually has a value of x raised to a whole number. And it is usually its coefficient is usually going to be a real number. That's about it. An example of a polynomial could just be x cubed, or we have pi over, let's say, a bajillion, right? 10 times 10 to the 189th x to the 200. I have no clue what that graph is going to look like. Feel free to put it in your own calculator. It should be pretty cool. And then just y equals x is a polynomial. But just by definition, if we had something like 1 over x, that would actually not be a polynomial. Not a polynomial. Sorry if my handwriting sucks. I'm at the bottom of my board. And this is because x is raised to a negative integer. And we do not like integers. That is something old pre-calcers say. If you are not already saying that, then welcome to pre-calc. We don't like integers. Right, guys? That's about it for polynomials, but let's go into something else. Let's go into end behavior of polynomials. End behavior is a really important thing to understand and know about polynomials. And I'll use the graphs. Let's go negative x, x squared, x cubed, and negative x to the fourth. Or let's also use negative x cubed just to have fun. When we have a polynomial, or actually, let's save this for later. It'll come back pretty soon, don't worry, guys. Let's actually talk about the characteristics of polynomials, or I guess the names of certain features of a polynomial. When we have, let's just say here we have a polynomial x squared plus 6x plus 6. The degree of the polynomial is always the highest power which something is being raised by. Here we have the power of 0, so it's definitely not that. 1, and then we have the power of 2 right here, so the degree is 2. The leading term is the term with the power of 2. Or not the power of 2, I'm sorry. The highest degree. So here that would be x squared. And finally, the leading coefficient is the coefficient of the leading term. And that here, let's say leading and that x squared as the leading coefficient is 1. If you don't see anything, it's usually a 1. If you see a negative, it's negative 1. And that's important with understanding end behaviors. End behaviors, which is how a graph ends or begins, usually positive to negative infinity. When it comes to something continuous, like a polynomial, it really depends on a few key factors, with the most important factor being the really the leading term. Sorry, I'm just spacing all of these because I want to give more space. so it's all clear for you pre-calculus out there. Let's go down here. Hey, what's up, guys? Let's see how many pre-calcs I can fit off my ass in this video. Okay. Actually, I'm so sorry. I shouldn't be saying that. Oh my god, that is so bad. I don't know if people are actually going to be watching. Okay. Here we see an odd degree for a function. And then one thing about odd functions is that they're always going to have opposite endings. Right? Opposite endings. So then let's look at it's the leading coefficient. Here, the leading coefficient, let's call that LC, is negative. So the graph is going to end at a negative infinity. That's what the negative always means. If you see a negative next to the leading term, just know you're going to end up with a pretty negative end behavior. So here, if we actually were to graph the equation, not the graph. Here's the graph, and here's the equation. We see that the graph forever goes to negative infinity as we approach, as x approaches positive infinity. And then as x approaches negative infinity, the y value approaches positive infinity. So just keep it in mind that when you see an odd degree, you go to the opposite ending. Yeah, like they're going to see opposite endings. And then when you see a negative, when you're approaching positive infinity, you're always going to have that ending of negative infinity. And let's test something out. Let's test that out here with... Let's actually test that out later. Let's go to x cubed. X cubed means an even degree. When we know even means like, you know, pretty equal. And like, you know, you can divide it by 2 and you always get a whole number. So it splits equally, and equal, the way I like to think about it, is same. So it's going to end the same way. If it ends positive infinity, it's going to be like that on both sides. Or it could be negative infinity on both sides. Here we see the leading coefficient is positive 1. So it's going to be positive. And that means if we were even just to show the graph, we see that as x approaches positive infinity, the graph, the y value approaches positive infinity. And as we approach negative infinity in terms of x, the y value goes to positive infinity. So here we see the same positive when we have an even degree and a positive coefficient. When we have a positive coefficient and an odd degree, we go to opposites. And once we go opposite, we can go look at the leading coefficient, which is positive 1. And we know that since it's opposite and the graph is positive, it's going to end positive, right? And opposite means what? It does not mean that. Opposite means that when we're going the other way, we'll be going to negative infinity. So that's how this graph is going to look like. So we know that as x approaches infinity, y approaches positive infinity. I drew the wrong graph. I was looking, I don't know, man. I'm sorry. And then as x approaches negative infinity, the graph approaches negative infinity. And finally, I want to test you on your skills of knowing degrees after this, because I want you to really understand that even degrees, which are like 2, 4, 8, 6, all of those, they all have the same endings, and it all depends on the leading coefficient, which here is negative 1, or just negative in general. And that means the graph is going to end up looking something a bit like this. And as we see, as x approaches infinity and as x approaches negative infinity, since it's the same, the y value ends up approaching negative infinity. And I want to test you on, I'll give you 3 questions. 1, 2, 3. What is the end behavior of these equations? Or polynomials, my apologies. I want you to take a minute, or you can, if you're quick enough, do it as I'm setting up the answers. And I will be starting now. If you haven't already, I'd say pause, get ready, unpause. Okay, let's go. We see an even degree, so we know it's the same ending, and the LC here is positive. So that means that as x approaches positive infinity, the function will be approaching positive infinity, and as we approach negative infinity, the function will also approach positive infinity. Because remember, it's the same ending, guys. Even is the same ending. And here we're at another even function. So we know we have the same ending, but we have a negative leading coefficient. So everything switches. And when I mean everything, I mean both endings, both of the same endings. So if it's going to approach negative, as if the end is going to be negative infinity, because really the leading coefficient is what the end behavior will be when you're approaching positive infinity. Here we see it's negative infinity. That means that negative infinity, it'll also be approaching negative infinity, because it is the same, it's the same, even degree is the same ending. And let's look at this question last, x to the fifth. We see that it's an odd degree, so that means opposite endings, odd opposite. And we see that there's a leading coefficient of positive 1, or really just anything positive. And so that since we know the ending is going to be positive, we can instantly say x approaches positive infinity, the y is going to approach regular infinity or positive infinity. But since it is opposite, no, are you kidding me? This is when I want to get that glitch. Let's try this. Man, I'm sorry, guys. And as x approaches negative infinity, since it's the opposite, the y will be approaching negative infinity as x approaches negative infinity. If you are confused with odd, the graph will look something like this. We can see that as x forever goes on to infinity, it's going up to positive infinity, and as the x goes to negative infinity, the y also continues to forever go down to negative infinity. That is it for end behavior today. I hope you all enjoy the video. See you later.